Hi, everyone. Welcome back to the closing session for the conference. I think it's been an awesome 3 days, 2 days especially for everybody on the regular conference and the workshops. So last but not least, we're gonna do our symbolic lightning talks. It's always a great opportunity for everybody to be able to present, and pitch their ideas, how they want everybody to participate and different things. So again, we have a full slate today. We have Chuck first, who's going to be presenting for 5 minutes on the Mongolian script, what's next. And again, the rules I'd like to follow is that, kind of have a 1 minute switch over between each talk, just for folks to get their laptops set up very quickly and then switch over. So with that said, Chuck, over to you.
Yep, thank you. Hello, everyone. My name is Chuck, and it's a great honor that having the 5 minutes here. So let's talk about the Mongolian. Okay, so if you look at the screen, you can see 3 letters, right? So it looks exactly the same. In fact, it's some person's name, so that it looks exactly the same now. So just double confirm, it looks exactly the same, right? Yeah. So then next step I'm going to do is I'm going to separate the characters one from each other. Then you will see some magic. So first step, we separate. Second step, second letter, you can see some differences. Third letter, you also can see differences. Number 4, you also can see differences. Number 5, you also can see differences. Okay. Number 6. Number 7 is the same. 8 and 9 are all different as well. Okay. So it is basically these 8 characters, all different, and then you combine it together. Let me combine again. Combine again. Exactly the same. So it's a magic, right? So if it is your name, do you know which one is your name? I'm looking at this, and then I want to find my name. I want to sign on a contract. I need to find my name. Do I need to split? Oh, okay, the third one is maybe mine, second one is mine. I cannot do this. I cannot afford to do this, right? So what is really happening here is, looks exactly the same, but underlying the code is absolutely different, because it's somehow it's been set up, it's like that. I don't know how to explain, so I call it magic. So yeah, so let's, and by the way, this is ex-president of Mongolia's name. So when he signed on a lot of contract, I don't know which one he's signing on, to be frank. Yeah. Let's look at another name. This is not name, this is about Batordolna, is about thinking about something, right? When you look at it, when I write this word, I have 3,072 options to write the same thing. I can write whichever the Unicode I can combine, looks exactly the same. But the code below is all different, right? So when you, for example, let's just look at this second O here. It has 4 different options. You need to choose. I don't know which one is correct one, to be frank. It will be based on education level, your local dialect, accent, I don't know. So if you're busy, you don't want to choose, right? You just randomly choose. And then it looks exactly the same. But the problem is when you search it, you cannot find it back, right? So the first O here, 4 options. Second, this one, you have 2 options. Another O here, another 4 options. And then you multiply all of them again. You have 3,000 options, 3,072 options. Only one is correct one. And now you tell me which one is the correct one. I don't know. So how am I going to search it? How am I going to use it? If I don't have a doctorate degree, I don't understand. Even the owner who developed this said, even the university graduate does not even understand this thing. which is true. It's a very precise script maybe, but it's not for my daily use. It is for scientific research, yes, maybe it's good. But for my everyday chatting, Facebook, WeChat, I don't know, I cannot find whatever I type, when I search back, I cannot find it back, right? That's a problem, that's a magic. And we are facing this for the last 20 years. And still, ding dong, ping pong is happening. I don't know how it's going to, I don't know. So sometimes we write a lot of things and then we cannot search it back. It is like, then why should I write it then? Why should I write it? Because whenever I write, when I search, I cannot find it back. Okay, so that's it. I only have 18 seconds left. And then, thank you very much. And please help us improve this. The reason I'm come to here is I need help. We need help. We need all your help. Thank you very much. Yeah.
Thanks, Chuck. Right on time. Cool. All right. So we have our next presenter, who is going to be presenting on Manish. I think it's you next. Aiding the adoption of neographies.
I was actually not sure. I thought 10 minutes was also okay.
No, 5.
It said 5 to 10. Okay, I can, yeah.
Yeah, I mean, again, skip over.
Yeah.
Go through it. Manish.
Let's see.
Yeah, then ZB, then Anton.
Let's see, did it? There might be an HDMI port. Oh, there we go. That'd be why. Oh.
5 minutes includes time for questions usually?
No.
If they finish early.
If they finish early.
Okay, and I want to mirror.
Is it your secondary? Yeah.
Yeah,
Oh,
I
shit.
agree.
Where'd my mouse go?
Okay, so, yeah, I mean, again, people can always answer questions at the end. You can pull them in.
So, okay, you can.
Yes. They can choose to do what they want
I
with their
lost
5
my
minutes. They could ask questions.
Oh, okay, so do I have to just bring it back?
All right, Manish, let me know when you're ready.
Oh, I see what happened.
You ready?
Let me get this to start. Oh, boy.
You're good.
And,
I can see your slides.
yes,
All right,
computers.
go for it.
All right. So this is a talk that I really prepared quickly in the morning because Anshu yesterday was like, you should talk about this. So I'm going to try to get this, yeah. So we have a lot of new writing systems that are being invented. Here's a chart that Debbie's group and some other people have prepared of all of the world's writing systems, or more or less. Oh shit. Oh no. What happened? Wait. I can't see anything here now. It was there.
Okay, I'm gonna plug it in.
I mean, if it's visible up there, it doesn't. Okay, so and then we need to mirror.
Where is your mirror?
Okay, I can. There we go. Mirror displays. Okay. All right. So we have this chart of. We have this chart of the world's writing systems. There are a lot of them, and a lot of them are new. They were created in the last century. Many of them are often places where the languages were affected by colonialism and their writing systems were replaced or never had one, and they don't want to continue having the trappings of colonialism. And often in West Africa especially, there's so many new writing systems, and basically we. Oh, there we go. the penguin's fault. All right. So the thing is that if you want to, oh, I see what happened. Okay, now I understand. Okay. The thing is, if we want to encode a writing system in Unicode, it needs to be in use. People need to be using it. I can't just go and create Manisha's writing system to write English and be like, all right, Unicode, do this. People need to be using it, and not just me. It needs to be other people. People need to be talking about writing in it and whatever. But how do people use writing today? Most people use it digitally. I rarely write. As I mentioned in the talk yesterday, I mostly just write when I'm writing like my Chinese homework. I don't actually write English ever. I text, and so do so many people who are using technology all over the world. So to use a writing system, it must be encoded. But to encode yeah. So let's go back to that. Does it have to be encoded? I mean, if we want to use it in technology, which is where a lot of people use writing these days, you kind of feel like it needs to be encoded, but there are ways around this. For example, Chuck, who just spoke before me, has written an app that lets you, Mongolian is encoded, but as he says, there are problems. So what it does is that it lets you type and it creates images. And people on Facebook are like sharing stuff in this form. They're using it in WeChat and other apps. Similarly, Gretchen mentioned this yesterday, that people who are composing, there's an app for doing this for hand spelling in ASL, and it is, again, using images because the hand signs are not encoded. So this is actually an interesting solution to cutting the Gordian knot of like this must be encoded to be in use, but must be in use to be encoded. And I just want to propose maybe someone should build something that makes this apps like Chuck's easier to write, like a reusable framework where you provide your own custom font that works on the PUA or something, and can totally just, and you build and you define the keyboard with like some specs, you make it fully customizable, and then you have an app that people can use to like send text to each other, because it's ultimately most texting apps support images. So you can just build a keyboard that looks like it produces text but really produces images, and we might be able to solve this problem. We might be able to have more writing systems come up because they're no longer like hindered by not being encoded. And yeah, it should be something easily replicable. Yeah, I kind of ran out of time, but yeah, I would love to see this kind of thing be built. I would love to see this kind of thing be shared. Talk to me later if you are interested. Thank you. Sorry about Linux.
Was right on time. Thank you, Manish. That was awesome. All right. So the next person whom I'd like to invite is Zibi. And Zibi is going to be talking about localization, QA-driven CAD tool user experience.
All right, my turn to struggle with technology.
I think you've got a Mac. It might be a bit easier.
Never.
Never, I know.
It'll be too easy. Where's the fun in it? What do you see on the screen? Do you see something on the screen?
Secondary
Excellent.
screen, so if you
Excellent.
present
Yeah.
present your-
I'll just, oh, maybe I'll go, maybe you're right. Let me see. Nope, I'm just gonna move it to the second screen. Yep. All right. Wait a second, because I need to see it here. It's going to make it really fun to show you the demo that I have. Okay. Yes. I'm not ready. Oh, no. Don't count it. Yeah, I don't know. I'm going to try to do mirroring. Do you see anything? Cool.
we see something? Look good? Yep.
Amazing, yes, ready. All right, so I'm one of the people, hi, I'm Zibi Braniecki. I work at Mozilla on internationalization. I'm TLMing the platform Intel team there. And one of the things we're doing is thinking about the future of localization systems. And I'm gonna talk about the localization systems from the hypothesis of the thinking hats and how people think about what they do and how they take personas when they operate. In particular, how localizers do this. Do not expect anything beautiful at the end, but maybe a way of thinking will inspire community to think about how localizers can in the future work with the localization tools. So to explain how it works, the thinking hat theory, something we observed fairly often at Mozilla is that our developers wear at least two hats in context of our work. So they wear a developer hat. Here is they write code and they think like a developer. And then they are the original translators. They translate our software to American English. And when they translate our software to American English, we don't want them to think like software engineers. We want them to think like localizers. Because unless we have a chance to work with copy people, we will actually use those translations that those original translators provide. So similarly, we can talk about how localizers wear hats. Here is a piece of cat tool that we use at Mozilla called Pontoon. It's open source, you can use it. That's the screen how people see it. And here you can see a snippet of it where you can see a source string. It's fairly long and rich, and below that there is a Polish translation of it. And when the localizer is interacting with it, they read at the top, and they type into the bottom, and they wear a localizer's hat, which is translator hat. But that hat starts being a little bit fuzzy when they start doing a little bit more. Our tool is not very advanced with helping and hiding the complexities, so when the localizer is interacting with a string that has a variable, they see something like this. And many of you can say, well, it's not that hard. They still wear a localizer hat, there's just a little bit of syntax in it. But I'm going to argue here that that's a slippery slope as we move forward into the future, because things are becoming a little bit more complex. That's a nuanced difference for you, but there is a minus in front of the brand short name, which indicates that it's a term, and that way of thinking about what you see and type is actually a developer way of thinking. It's definitely not a localizer way. And that can become much more complex. Here is an example of Fluent, where the tap count creates several variants of the same message. Message format 1 has the same problem. Here is a localizer interacting with or typing a gender selector. And with Fluent, it can go further when you have a nested selection that becomes really complicated and basically a developer-based, the developer hat is worn by a localizer. And what I'm here to argue in a minute and 50 seconds is that it's not going to get easier. The requirements that I imagine in 2025 for localization system will include things like human-like communication, bots, machine translation, voice assistants, dynamic interactive user interfaces, and grammatical features in languages that many of us are only now starting to try to tackle technically. Message format 2.0 tackles it with extensions, genders, grammatical features, multi-selectors, case agreements, and so on. And my prophecy is that it's not going to make it easier for a localizer. Since it's not going to make it easier for a localizer, we want to avoid the dark case scenario where localizers must think like software engineers when they localize, in particular when they localize. So we have two heroes, I'm sorry for spelling. The one are cat tools that can save us, and the other is semantic data that we can provide between localization and a developer localizer and the tool. So in the developer hat like this, instead of that, we start thinking about providing some user interface that derive the right plural category in forms for the system. So you can see that in Polish there are 3 forms, not 2. And here we see the same tool helping you select the access keys for the message without thinking like a developer. And now I'm going to try in 30 seconds to show you a demo what I'm talking about. Here is an idea of a tool that does it further. So you see a message John wrote to you, and I will say, John wrote to you. I'm going to hover over the gender, and it says, Mary napisał do ciebie. I can tell that it's not right in my language. I'm wearing a QA hat now. So I'm going to say, actually, it depends on gender. And it'll say, which one is incorrect? I'm going to say, this one, it should be A. And it produced a localization message that depends on a gender without me ever thinking like a developer. And I believe that we should explore this area in direction of CAT tools, and message format to 0 can work with it if we have localization support in building semantic data. Thank you so much.
Thank you, ZB. Just in time. Good stuff. All right, next, Adil. So Adil will be presenting on BiDi from the user's perspective. And we'll give him some time to get set up and then start the talk.
All right, nice out the way in. Yeah, there we go. Right, let's see what we've got. Okay, so let's hit play, see what happens. Right, so, yeah, hello. This is like an extension of previous BiDi talk I've done at this conference, and I thought I'd start with this is my life in general. So here is the BiDi map. As you see, if you go left to right, you start from the start, and if you go right to left, you start from the beginning. But there is no end. So that's how it is, and I've been at this for 30 years, and I'm quite sure, yeah, there's no end. So I've only got 5 minutes, so let's start really, quickly. So here is, let's see if you can see that. That's quite visible, yeah. This is an old Sumerian stone relief that I saw in a museum in Germany. And it shows a king and one of his priests, I think, worshipping the god of writing, which is symbolized by the clay board and the scribe, the pen. Well, we wouldn't call it a pen then, but whatever stick they call it for writing in cuneiform. So in those days, writing was really important. And if you think about it to the modern day, we're still worshipping it in the same way. So yeah, in those days, Unicode Consortium were the gods. But jumping forward a few years, since I've only got 3 minutes left, this is the first word processor I worked on. And the interesting thing was that they attempted to match what you saw on the typewriter. And that was really great, because people could just type away on the screen, and they know when they print it out, they get the same result. That magazine name, by the way, they could have get away with that in the 80s, but not anymore. But that was the Apple magazine for the UK. And then great engineers from Silicon Valley came along, and they modeled the word processor on their understanding of the computer. And you had the backing storage, and in a way, that's where things started to go wrong for BiDi, because you end up with examples like this, where logically in the backing store, you know what you're doing here. You're selecting a single contiguous set of characters, but you've got to then kind of mash around the user interface from that. So what I wanted to talk about is, what if you could just take that concept, that idea, and say, look, how about we do this from the user's point of view? So this is what most word processors will give you at the moment. And if I want to do something like select the number 3, no. It's not kind of working. I know I have to actually start from the 2 and then get to the 1. It doesn't make sense for a user. And this is where the engineering model is trying to mimic the user experience. But here is another word processor that I had some contribution to. Again, I'm in my own individual capacity here, so I'm not talking about companies, but that's what the user wants. And it looks extremely simple, but I actually had to pull out the internals of the word processor and say, no, you've got to do it this way. Of course, there are other issues. So for example, on this one, let's just switch to an Arabic keyboard. If I type here a number 4, it goes there. Why? But here, I put the caret here, type a number 4, it goes here. But then what happens if I put the keyboard here and type an Arabic letter? It goes there. two completely different things. But what's happening is I've got a caret that says, this is where I want to insert. Why don't we insert the letter there? Now, the reason I'm giving this talk is not just to say, great engineering, this is what's done. But this model here, I cannot replicate on the web because web standards are so tightly integrated to this concept of a single selection. You can't break it apart and say, look, let's have these multiple runs. Let's have this caret that doesn't actually exist in a single place. So that's the point I wanted to get to with my talk. Back to Keynote. Yeah, I want this. This is the right way. And as engineers, we have a responsibility to the user to give them the experience that they're expecting, not the experience that we expect as engineers. So, 13 seconds, I'll show you some of my favorite calligraphy. And the great thing about this is when it goes into a new culture, you get stuff like this. And that's it, really. Thank you.
Awesome. Thank you, Adil. That was great. Right on time. Thank you again. Okay, I think the next person we have is Peter Constable, and he's going to be talking about better font technology for the world scripts. So Peter, just say when you're ready. You mean to say the carrot cannot stabilize anymore?
Yeah.
Do you need your...
It's the wobbly font.
Can I try?
Did you kill the adapter? Back to tutorials. Reset. Oh, those are bunnies.
Do you have a personal dongle that you use?
I don't.
Let me try.
Those are bunnies in Matsue.
Every other conference, people have trouble with Unicode in their presentations, and at Unicode conference, we get this.
Unicode has been solved here. Exactly. The tough problems solved. It's the easy ones.
So while we're waiting for this, I'll give a little preamble. So, part of my role at Microsoft is maintaining the OpenType font format specification. And when I say maintain, I mean, like, what are the future enhancements? What's the future of OpenType? And so I want to talk about some ideas of enhancements that we might be able to add into OpenType that can provide improvements, better fonts for the world scripts. But we'll wait until you can actually see what I want to talk about. What's that? No.
Hold on one second.
Okay, next year onwards, we're going to do, you're going to share the Google Slides with me, and I'm going to just use one, one system.
Well,
I'm going to use one.
Once we get this working, Sam's got her presentation in mind.
All right, cool. So we're good. So for those of you who didn't know this, we have a
Is it taken?
email ID, getinvolved@unicode.org, where you can actually, if you're interested in working on a particular project or proposing a new idea, should be able to, just reach out and have a conversation. We'll help you figure out if we can help you.
Is it on? Is it taking it? Oh. Wait.
Should we swap order on the talks?
Let me try.
Sorry, everyone, just to borrow 30 seconds when they are still working. Yeah, so the reason the Mongolian code have a lot of problem I showed you, I think that's a major problem. So one of the major problem, we already have the solution. To be frank, we already have the solution. It's easily, very comfortable using. The problem is we need to get it approved, but then the space is already taken by the previous, that lousy one. So that's the thing, they're staying there. We cannot do enhancement there. And our new one also have nowhere to go. It's just stuck somewhere. So please advise us, it's not only me, it's like we have millions of people trying to use it. And Mongolia already officially announced they are going to use it by 2025, but we don't even have a clear script. Okay, we have big problem. I think that country is making a big mistake because their script system is not even ready, and then they are announcing big thing. But so please help us.
Is it
Thank you.
could potentially,
All right, Chuck.
well, I could.
Or it's an adapter problem, actually. Peter, would it help to use my system? You have a Mac. Very
Oh,
weird.
we'll try it. I have a feeling it's not the dongle, though. Is it, want me to look at the scalar?
It's the adapter. Should we
Wait, don't.
do a couple of other talks and then come back to Peter? Peter, should we do a wobbly slide deck? It's fine. Yeah, because we'll run out of time for the others. Can we just do the others and then come back to Peter?
Let's try that once.
Once more? All right, otherwise we'll skip. So Sam, oh, whoa, okay, good work. All right, we're almost there. Okay, this is not wobbling. Yay.
All right.
Peter.
Okay, so I mentioned some ideas for improvements in OpenType that can potentially benefit the world scripts, providing better fonts. And I'll just give a caveat up front that there's no guarantees here. These are ideas, but doesn't mean that they'll actually end up becoming a standard and implemented everywhere. Implemented everywhere is really key. In my mind, when I think about what's good future possibilities for OpenType is it ultimately needs to work everywhere, because what's most important is user documents. And users need to work with their documents in unconstrained environments. And so OpenType success means any new font capabilities are widely supported. That means I need to really be engaging with all the major platform vendors and application developers to get on board with new ideas. So I'll mention 3 specific ideas. One is breaking the 64K glyph barrier. If you're familiar with how fonts work, you can have no more than 64K glyphs in a single font. We already know that like Unicode 14 has over 144,000 characters. Just CJK is over 93,000. So you can't make a CJK font that is complete. And Debbie just mentioned to me this week that for Egyptian hieroglyphs, once the next set of hieroglyphs are added into Unicode, correctly render that, we'll need more than 64K glyphs. So that's one problem that solving. For the I have to give you a little background on variable font technology. So this was an enhancement in OpenType that was introduced 5 years ago. We had collaboration between Apple, Adobe, Google, Microsoft, other companies to design this enhancement. And the basic idea is this. Today, in the past with typical fonts, I might have a regular font and a bold font. I've got the outline data for the same letter. They're different outlines, and they're in 2 different font files. But there's a lot of duplication of information in those 2 pieces of data, and there's a different way that you can represent it, which is to say instead of 2 different outlines, I can have one outline, so the outline that's in red here, and then I can describe how you have to move the Bezier control points to derive the other outline. That's what a variable font does. It's a single font that has that kind of information, so you can represent an entire family of fonts, single font. And so that allows you to do things such as this. A single font where the glyph can stretch out in different ways to give you different variants of the glyph. So a key with a variable font technology now is that the font can have multiple axes, but when you pick particular parameters, that's a font-wide setting. Here is variable components. If you're familiar with Han ideographs, we organize them in terms of a radical that is a fundamental part of the ideograph plus some number of additional strokes. And so that radical gets repeated inside the character. Fonts will typically create the glyphs for a particular character often using components. They take a piece they design as one glyph and then they reuse it in other glyphs. But if you look, you'll see in this selection of glyphs that I've highlighted, you've got that radical repeated, but it has different shapes. So in some cases it's taller, in some cases it's shorter. You can't just apply a transform to squeeze it down because the strokes would end up changing. Here the strokes are constant, but there are these parameters. It's got different heights, there's different size of gap between the 2 strokes, and then you notice the arm in the lower right. It stretches out to the right in varying degrees. That's the basic idea of variable components. You use the variable font technology, but have a component-specific variation setting that say, when I bring in this glyph has a component, I select certain parameters for that glyph. If we do that, we can make a very, very large reduction in size of CJK fonts. So, yeah, we'll jump past this. The third thing is, again, this idea of having per glyph variations. And I want to relate it to Arabic justification. If you're familiar with Arabic justification, you're probably familiar with this idea of kashidas. In lead type, the typesetters would take flat pieces of lead and insert it to stretch out the glyph. And that idea of this flat stretching was carried forward into digital type. So you'll often see these pieces of Arabic text where you get these flat stretches. This is an example that represents kind of the state of the art in OpenType today. OpenType has a justification table, and in the justification table, you can say, all right, here is a Kashida glyph, and so the layout software can take that glyph and insert it. So if you look at the third word from the right, and in particular the second letter, which is the lam, the second letter from the right, as the column width is changing, you'll see the leg of the arm of the lam is being stretched out with insertion of this flat extender. Also notice the last letter in that word, the nun, where when you get to a certain width, suddenly it jumps to an entirely different shape. That's another mechanism that can be used in the justification table, where you can say, well, I've got some discrete variants of this glyph, and I can select them. But that's not really how Arabic script works. The idea of kashida is really extending, stretching the strokes that a calligrapher would write. And that's something that we could do with variable font technology, where we could say this glyph can be stretched out, it can be extended in particular ways. This is a prototype that was done by a couple of font developers, so this is actual digital type, and they justify the column by inserting, by changing the parameters for specific glyphs at particular points on the line to get the extended curve strokes that you would really want. So that particular presentation was at a conference in 2018. Fabulous presentation. Anybody interested in Arabic type, strongly recommend that. That's it.
Peter, thank you. You're over time. All right, Sam, I think you're next. And we are going to be talking about emojis all the way down.
She's going to use.
Oh, sorry.
Are you ready?
Yeah.
Okay, cool. Go for it.
All right. Okay. Hi, everyone. All right, so I'm talking about something a bit less technical than a lot of the lightning talks have been here so far. So my name's Samantha. I work on the emoji subcommittee, and I work a lot with incoming external emoji proposals. So as a lot of you probably know, you can propose your own emoji. Anyone can do it. And you might be surprised to hear that we get a lot of emoji proposals. So this is probably a pretty familiar image to a lot of people. I thought it was really cool when I first saw it, but if you are familiar with Unicode, you're probably really familiar that this is the first set of emojis. So this is 1999. They're obviously pretty basic, and I just looked this up. There are apparently 176 of them in 1999. In 2010, Unicode released their first set of emoji. I didn't look up how many it was. I think it was like a few hundred.
722.
Thank you, Peter. Okay, they released 722 emoji in 2010. So here's 2010. This is the list of emoji added in the next set of Unicode in 7.0. You're not supposed to be able to read that. I just took a screenshot of how long the list was. Pretty soon after that, the ESC decided that they're going to start opening the gates to external proposals. As you can imagine, things escalated pretty quickly. So this is an XKCD comic from 2017, and this is a screenshot I just took earlier today of the website called Emoji Request. You can see basically there's a lot of ideas out there for emoji that we could have or should have with varying degrees of like quality. So we get a lot of proposals. You can see here we've got 5 or 6 just of cannabis leaf alone. In fact, that's still not all of them. There's another one for pot leaf further down. And then I think there's still another one called marijuana lower than that. So we get a lot of proposals. And one thing that I found when I came to the ESC around 2019 was that there are just so many coming in, and we wanted to obviously find the good ones and make sure that like very cool, worthwhile proposals don't get lost, but then also not spend a ton of time dealing with, you know, the 7th cannabis leaf proposal. So who here has actually like proposed an emoji, like has submitted an emoji? I know Jenny has. Okay, a few people, cool. How many people have like successfully passed an emoji? Okay, good, all right. So you have an unusually high success rate. Probably because you're familiar with Unicode. The general public, I don't actually have like stats for you, but you know, it's probably not a huge surprise to hear that a large number of the proposals don't actually get added. So these are the instructions that are still available on the web. In 2020, we took a break during COVID, and I started sketching out basically a way to try to handle all of these proposals. So we redid, we updated this, the submission instructions a bit. So this probably does not look super exciting, but I love that very concise little bulleted list. It's way better than it was before. The people who have written proposals and submitted them, if you remember, like it might have been a while, but it's very detailed, labor-intensive instructions. So we want to help people like do that well and do that correctly to help them get their, you know, make their emoji dreams come true, and also help us, you know, not spend like a millennium going through, you know, not great proposals. So here are a few changes we made. And one of the biggest ones is we came up with basically we're going to have people submit proposal through a Google form instead of just sending in like a PDF or whatever, and then everyone on the committee would read the PDF and try to judge how good it is and look up all this criteria and stuff. So if you go to it now, you cannot actually submit one right now because we created a season also. That's another change, is you can only submit emoji proposals in the summer basically. But if you do submit it next year, you're gonna see stuff like this. So these are some of the requirements. You've got to turn in like frequency stats. We make people like sign kind of an agreement saying they followed the instructions. People still lied, but mostly they followed the instructions. So they would have to actually include screenshots for elephant. If they said like, no, I didn't follow the instructions, they would get a nice polite little message saying thanks for your interest, but no, we're not gonna read it. And it gives you just kind of more data on if it's been proposed before and so on. So it's not open right now. We're still kind of working on that. This is what you'll see if you go to submit a proposal right now. But once we opened up again, I can't give you, you know, again, any stats, but I think it made it a lot easier on us within the ESC to try to help the general public understand us. That's it. Thanks, guys.
Thank you. All right, great talk, Sam. Thank you.
That one goes away.
Yeah.
All right, and then while Jenny's getting set up, she's gonna be talking about Hanmoji.
I am. Plug it in. Other side. Ta-da! Did it happen?
And you're right after.
Why is it thinking so hard?
It's there, it's just booting up.
Is it also doing the spinny thing?
Haha.
Oh, let me go. Okay.
You can see
Mine is also a bit lighter. So I'm Jenny Lee. I'm on the emoji subcommittee, a vice chair, one of many. And I'm going to talk about emoji. So in 2019, I came and gave a presentation that was very academic, analyzing Chinese radicals to determine semantic gaps in emoji. And it was sort of an analysis and comparison of Chinese radicals, of which there are many, 214, and comparing them in terms of their parallels to modern day emoji. So there's fire, there's mouth, there's tree, there's moon, there's sun. There are a lot of things that were consistent, back in the ancient days when the Chinese were creating their written language and emoji today. And of course, there's the whole kind of beauty of mixing and matching the Chinese characters, which we kind of sometimes see in emoji today. So you take two trees, you get a forest. You take a sun and moon, and you get the word bright. This one's kind of fun. You take a roof and a pig, and you put them together, and you think like maybe this means farm, but in fact it means family or home, because that's, home is where the pig hangs out in the house. One of my favorite characters learning, Chinese growing up is obviously woman. As you can see, it sort of looks like someone crossing their curtsying. So then you take a woman, you put her underneath a roof. You're like, oh, that might mean family or home or something, but no, it actually means peace, because things are at peace when the woman is under a roof. Then my personal favorite growing up in Chinese school was like you take a woman and you put her with a boy or a kid or child, basically, and you're like, okay, that finally means family. No, it actually means good. So the standard for good in Chinese character encoding or whatever is like a woman who has a baby, preferably a male baby. And of course, the woman radical gets really interesting. 3 women means evil. This one means greedy. This one means slave. This one means envious. I think, yeah, this one means envious. And this one means like adultery or betrayal. A lot of analysis. I spent a lot of time looking at all of the radicals and sort of mapping them. And, with emoji, all you have to know is there's, like a lot of emoji kind of map into Chinese characters. Some of them don't. Here are some potential future emoji where there was a Chinese kind of radical, but there was no emoji. And I think bean actually out of this became, I think is coming. I don't know. I always forget like what we're allowed to say or not to say, but I think bean is on its way. So, I identified a bunch of semantic gaps. I was very proud of this. One of the areas of semantic gaps is on textures. There's like skin, hair, leather, fur, bristle, all in Chinese radicals, not in emoji form. So what should I do with this, academic work, of which we also presented at a conference? I think it's called, it's WebConf now. It used to be called WWW. And so what we decided to do is actually create a children's book, and that will be coming out in July 2022 from MIT Press. I am not kidding. We actually just got the page just went up. These are me and my co-authors. We're all of Chinese descent. And, it has like some of the stuff that I showed you in terms of like the progression of characters into emoji, also the combining like 1 fire is fire, 2 is inflammation, 3 is flames, also, people, crowd, if you add 2 of them, it's to, follow, and then 3 is a crowd. We talk about the alphabetic versus visual languages in terms of, there's a Cyrillic alphabet, Arabic, Roman alphabet. We kind of do some fun things teaching kids how to combine existing emoji for Chinese concepts. So in this case, it's Dian now, which means electric brain, which means computer. This one is wood ear fungus, so moor, and he made which is a good thing that the ears are now can be brown. This one is XLB, like xiaolongbao soup dumplings, which is basically small, like bamboo or small, long, like kind of like or a cagey kind of thing, and then bao is I guess like bready thing. We take a tour through Chinese idioms. This one is Ren San Ren Hai, which means it's like, a sea of humans, and you can luckily, kind of convey it in emoji should you want to. And then there is kind of like randomness, mama, hoo hoo, which is like horse, horse, tiger, tiger, for whatever reason. You can also convey that in emoji. We got like, we talk to kids about the 5 Chinese elements, and there's a lot of sort of discussion of like the history of Chinese characters, also parallel through emoji. There's lots of exercises, can you match the Sumerian, Mayan, and traditional characters below with the zodiac emoji on the right. And of course, as any children's book on emoji should have, there's a whole section on Unicode. So if you are looking for
That is so
a
cool.
Christmas present for your favorite 10-year-old, you can pre-order the book on Penguin Random House as of today. And, you know, who knows? You might have a whole bunch of 10-year-olds joining Unicode as individual members for $75. That's it. Thank you.
Great. Thanks, Jennifer. Awesome talk. All right, next we have Jeanette. And Jeanette's going to be talking about the International Decade of Indigenous Languages from the Translation Commons.
And I won't even try the computer. Hi, everyone. Jeanette Stewart. I wanted to share with you something which is open for everybody in the room and everybody you know to contribute for the International Decade of Indigenous Languages that is coming up. So as you know, in UNESCO, who is heading the decade, is basically working with member states, all the countries that are part of UNESCO, to create policies for indigenous languages. And in this effort, they have multi-stakeholder partnerships, and we have just been working over the last year and a half to create a global action plan that would enable all these partnerships and all these different stakeholders. This action plan is a 40-page document which has just now been released the last couple of weeks and is open to consultation. So the 40 pages consist mostly of bureaucratic political talk and words. You can skip through that. What it is very important for us to do is look at the frameworks and look how is it that we can help communities as an organization, as Unicode, as Translation Commons, our organization, but also as individuals, as experts, and as corporations. How can we get involved with this? And this is our only opportunity to actually make a comment. So if anybody is interested, please give me your email. I will send you the link. I only have it on an email, so I can only forward this email to you, which has the document attached and the link to the form that you can make all the comments. They do seriously read all the comments. So this is our opportunity to actually put some concrete, actionable plans and deliverables that we can do. Thank you.
That was fast. Thank you, Jeanette, for saving a... No, totally. So if people have questions, feel free to ask. We have a couple of minutes.
Will I accept emojis?
Specific emojis. Any other questions? We still have 2 minutes.
Oh, yeah, for me?
Otherwise, we'll move on.
Any questions for any of the other speakers?
Yeah, any of the other speakers? All right. Chris, I think you're next. I'm looking forward to Jenny's book.
I need to mirror.
So Chris is going to be
How do I
presenting on
sketch my mirror,
fonts
so-
and text rendering stack.
Okay, so now,
2 more talks after that. So
okay, is that showing? Yeah, it's showing the same thing. Awesome.
slightly over time, but not too bad.
I can take this off now. Okay, testing 1, 2, 3. Hi, everyone. So my talk is fonts in the text rendering stack, or how Unicode characters become glyphs on your screen. So you've probably, so for those of you who are newer to Unicode, you've learned a lot about the character encoding and so on, but you might have wondered how does it end up on my cell phone screen or my laptop or what have you. So if you get nothing else out of these 5 minutes, please come away with the message that a character is not a glyph, and it's not even necessarily a one-to-one relationship. If you learn nothing else from me, please learn that. It's the most important part of my message here. So here's a super high-level overview of the stack that gives you glyphs on your screen. You have a font at the bottom. There's a piece above it called a rasterizer that draws the glyphs. There's two pieces sort of side by side above that. There's the shaping engine, which gets you the right glyph for the context and puts it in the right position relative to other glyphs. And there's a thing called the BiDi engine that puts your left to right text and your right to left text in the right order on your screen. And on top of that, there's a piece called the layout engine that like lays out paragraphs and moves text around pictures on the page and so on. So I'll touch on everything below the layout engine as quickly as I can here. So starting with fonts, this is the directory of a font. This is from the Adobe Arabic font. So on the left-hand side of the screen, you see all these tags like base, CFF, DSIG, and so on. On the right, you have more of an English description of what those tables are. I'm just going to focus on a few of them right now. The first one and the most important one is called the CMAP table. This maps the Unicode character to glyphs in the font, and it maps them to their nominal form, which I'll get into in a minute. So here I've picked out the exclamation mark. The Unicode for the exclamation mark is 0021 in hex. In this particular font, it is the 874th glyph. Okay, in another font, it could be glyph 5, it could be glyph 200, it could be anywhere, but in this particular font, it's glyph F874. So if we look at the list of glyphs in this particular font, we see 870, 871, and so on. We get to 874, and lo and behold, there's the exclamation mark. Well, what's actually stored in the font is a collection of essentially points with instructions of like what kinds of curves and things you want there, so you can draw an outline of that glyph. And that rasterizer software I mentioned earlier is what actually draws in the glyph on your screen, so you get a solid form like this. Now, for Latin writing, its most basic form, that may be enough, but for a lot of writing systems, that's certainly not enough. So you have other tables in the font, like one called gsub, which gets you the right glyph for the context. So in this case, I have an Arabic lam and an Arabic aleph on the top that are the initial and final form, but what I really want is the ligated form, which is the green form you see on the bottom there. So this is a ligature, this is actually called the required ligature feature in this font's gsub table. Likewise, if I'm typing and I have the letter be in Arabic in the middle of a word, I want the medial form, not the isolated form. So on the top, you see the isolated form, and the bottom here in green, you see what's called the medi or medial form, which we're getting through gsub. Now, in partnership with gsub, we have another table called gpos, which is the glyph positioning, which puts things in the right position relative to each other. So here we have, again, our friend be, which is the medial form on the bottom, and we've got a diacritic above it that's right above the sort of the tooth of the be. But if we have a final form of the be, we want that diacritic to be centered over the curvy part, not the tooth. So gpos table has that information. And the software I mentioned called the shaping engine uses the gpos and the gsub to get the information based on the context of the Unicode text it's got, in conjunction with a third table, which is called gdef, which is the glyph definitions table. And so that has like base glyphs, mark glyphs, ligature glyphs, and so on. We've heard a little bit about BiDi earlier, so I won't go into it too much, but just know that there's this thing called the BiDi engine that puts the characters and the glyphs in the right order. So here's a quick example. So here I've tried to write salam, but I haven't used BiDi or gsub yet, so the glyphs are in the wrong order and they're not connected. So I turn on BiDi, now they're in the right order, still not connected. I turn on the initial feature, then the medial, then the final, but I'm missing a ligature, so I turn the ligature feature. Now I've finally got salam in the form that I want. So now all these different pieces I mentioned, if you want to learn more about them, there are open source projects you can go and look at. You can use these in your own software. You can use them as reference points for something that you're trying to write. So even the fonts, they're open source fonts like the Nodo and Source families. I've listed the names of the other projects here. And in my few seconds left, I just want to close with the message I opened with. If you learn nothing else, the most important thing for you to learn is a character is not the same as a glyph, and there's not necessarily a one-to-one relationship. Thank you.
Awesome, Chris. Thank you so much. That was great. Again, a character is not equal to a glyph.
Pardon? Yeah, you can have one to many, many to one, or many to many. So,
multi to multi applies in your use case. Yes. That's true. That's true. All right. May I invite the next person, Eric? And Eric's going to be talking about time zones.
Yeah, looks right. Okay.
That looks just right. You okay? You want to start?
All right, yeah.
Okay, let's get started. Go for it.
All right. Hey, everyone. My name is Eric Nordin. Let's see. Actually, sorry, this is only displaying the top corner of the slide. All right. Cool. Now my name is still Eric Nordin, and this is displaying the whole slide, and I am a software engineer at Mozilla, and I have been working on time zones for ICU4X. So time zones are extremely fun to work with. They cover the whole world, if you didn't know. They range from minus 12 hours GMT to plus 14 hours GMT. And they're not always right on the hour. There's some really fun ones, such as the French Polynesian islands here, which are minus 9.5 hours. And one of my other favorites is the Jarvis Island, which is at minus 11, which is right next to the islands that are plus 14. And I always wonder if the people there like fly back and forth and travel between different days. It seems like a lot of fun. I'd love to visit sometime. So I'm going to talk a little bit about some of the terminology that we talk about when working with time zones. There are the time zone identifiers, often abbreviated as TZIDs. Now, the TZID may refer to a city, country, or territory, such as Europe, Helsinki, or America, Puerto Rico. In CLDR, the time zone ID is locked in once it's created, so it'll never change. One example is Ponape, which used to be spelled P-O-N-A-P-E, but now is spelled P-O-H-N-P-E-I. And so in CLDR, it's stuck with the original name. However, in the IANA time zone database, those can get updated. And so there becomes a discrepancy there that we have to keep track of, which is lots of fun. And time zones also have an exemplar city, which is an exemplar location associated with the time zone ID. The nice thing about that is it may not be a city at all. For example, the exemplar city for Puerto Rico is Puerto Rico. And these may be updated over time. So the exemplar city for Ponape has the up-to-date spelling, which is nice. And then in ICU4X, we are calling the daylight and standard time variants, which I don't think is an official name in a spec, but one of my favorite examples pulling from the time zone database is in April 30th, 1933, Hawaii said, all right, yeah, we're going to give daylight savings time a try. And 3 weeks later, in May 21st, 1933, they were like, yeah, we're Hawaii, we get enough sunshine, and daylight savings time isn't for us. We don't need to save any daylight. So, but when you are doing time zone format and you are formatting a date, if you happen to be formatting a date in those 3 weeks, you better display daylight savings time for Hawaii. Also, we have the meta zones, which are a grouping of time zone IDs that share a display name, such as Pacific time, which could be for Vancouver, Canada, or for Los Angeles. We also have to keep track of when places belong to the meta zones. So Knox, Indiana, up until 1991, decided to be in Central Time, but then from 1991 to 2006, they wanted to be Eastern Time, and now after 2006, they're back to Central. So that's also a lot of fun. Then we have all the time zone formats, generic non-location, partial location, all of these, which are specified in the UTS 35 specification. So like when you're formatting dates and you have YYYY, MMDD, we also have all of the time zone pattern symbols, O and V and X, and all of those. And I've compiled them into a little table here of all of their patterns and what they need to fall back. Because if data isn't available, we need to fall back to different different forms that do have translations. And then in ICU4X, we try to match that exactly. So here's some of the code. For example, if we got one lowercase v, we would do a short generic non-location format, or else we would try doing a generic location format, or else we would do a localized GMT format, and so on. And speaking of IC4X, if you are interested in being a time traveler as well, and you like Rust, and you like programming, you are welcome to come contribute. I'm happy to mentor bug, sorry, in Mozilla we call everything a bug, mentor just items to work on and things like that. And yeah, we would love more contributions, and or if you just want to come check out and use the project, that would be lots of fun. Thank you.
Cool. Thank you. Thank you. All right, and thank you, Eric. And last but not least, we have Eunice presenting on units.
Let me just open it first. Yes. All right, let's plug in first and then we'll launch it. Give it a second.
Clean units. So it's cool.
Okay. Hello, everyone. I'm Yunus from Google Switzerland. So we are going to talk about I-18 units. And we are going to start about fairly example, like someone from Switzerland asking how's the weather to someone from USA. And then the reply, it's a little bit hot. It's 100 degrees today. So what? So 100 degrees Celsius, actually 212 Fahrenheit. So wow, you can't survive in a boiling water. He's confused. So the guy from Switzerland, he's now, okay, the people in the US use imperial measurement system, so they use mile, yard, foot, and inches for length. So now the guy from US, how tall are you? So 1.9 meters actually equal 0.01180 miles. So he gave this his answer. Still confused. Okay. So here we go. So now he understands, okay, the people in US, they use miles and feet for roots and feet and inches for human length. So now, how tall are you? Okay, so he said 1.9 meters equals 6 feet and 2.8032 inches. So this is very accurate, like, for this. So he's still confused. So the idea is now he realized that the people, the human length, they calculate the precision to the nearest inch. So now, how tall are you? 1.9 meters equals 6 feet and 2.8032 inches, and it will equal 6 feet and 3 inches. So now he's happy. Okay, so we learned from this that if you want to know the measurement in some country, you need to know 3 things. First of all, you want to know the locale. So because of this, you can understand what is the measurement system, and also what is the language you are going to present this measurement system in. The other thing is the usage. Is it like for human toll, for road, for like human waste or whatever? So you need to know this. The other thing, you need to know the value, because for example, in the road, if it is like you are going to take the turn after half mile or more, you are going to represent the value in miles, but if it is less than half miles, it's better to say, okay, it's like 200 feet or something like this. And thanks to CLDR and ICU, they are now supporting this. So by just having a number formatter, passing for it like the measurement that you need to enter, which is meter, and also the usage. So once you give them the usage, like person height, or for example, route distance or whatever, so magically, once you see for local English US, you give it 1.9 meters, it gives you 6 feet and 3 inches. So the one who's received the message are not going to be confused, are going to be happy from the first time. So wherever you change the locale and language, you will get the correct measurement system converted and represented for it. So what is next from this? So the idea is we support around 32 usages right now. We would like to support more from this. So if anyone feel like this is something very important for their applications and they want to support more usages, please contact us. So Eunice at Unicode or Shane at unicode.org. Thank you very much.
All right, so Eunice, you're way ahead of time.
So any questions?
Any questions? Is this a library that you can use?
Yeah, it's
Is there an
already,
API?
it's already
Is it an
live,
omni?
and this is actually live code that people can use it from ICU directly.
Oh, cool, cool.
Yes.
That's awesome.
Oh, there is a question there.
Yeah.
6 feet and 3 inches.
We can all parse that. Cool. Thank you again. All right. I think we're at time. We actually went through our whole list of speakers, so this is awesome. Yeah, and we're definitely over time, but 5:30 on the dot. And I think Mark is not here. Is Toril here? Toril, would you like to do the closing remarks? Would you like the mic?